So factoring trig equations can actually be pretty hard yet rewarding. However, there are just three main cases that you need to wrap your head around. So first one is really straightforward. You're just going to look for what all the terms have in common. So I have a tangent squared here and a tangent squared here connected to the sine squared. So all I'm going to do is factor out a tangent squared. I'm going to do that here as shown. Tangent squared factored out here where 1 would be, right? And I get tangent squared times 1 minus sine squared. Well, 1 minus sine squared. If I look over at my Pythagorean identities, I know that sine squared plus cosine squared is equal to 1. And if I subtract sine squared, I get cosine squared is equal to 1 minus sine squared. 1 minus sine squared, 1 minus sine squared. So I'm just going to rewrite it again as tangent squared times cosine squared. And finally, I'm going to rewrite my terms in terms of cosine and sine. So I'm going to rewrite the tangent as sine over cosine squared. The cosines cancel out. I'm finally left with sine squared. So fairly easy. In that example, we find what's in common and we take it out. Next example here. A little bit more complicated, but still doable. We have an expression. They don't all have something in common. This one doesn't have a tangent, whatever. But I do see that it's decreasing in power, right? And that's very characteristic of a quadratic equation. So I'm just going to say let a equal tangent squared. And you'll see where I'm going with this in a second, right? And I'm just going to say a squared plus 2a plus 1. You may be wondering, where did I get that from? Well, if I let a equal tangent squared, right? This is so I can save space in writing. Instead of having tangent squared and then squared again, I'm just going to put a squared, and then same thing with here and there. Now this makes it easiest for me to factor it out in terms of factors like these. And when finding your factors, you want to make sure you can FOIL it out and get the same thing here and here. So I checked and this would work out. Now all I'm going to do is replace what I let a equal. A equals tangent squared. So I'm going to rewrite that. A here, tangent squared here. Right? Now again here I see identities. Tangent squared plus 1. You can refer back. That would be secant squared. So I have secant squared times secant squared. Or finally secant to the fourth. So in this type of problem, I didn't necessarily take anything out, but I noticed that a was a quadratic form, and I could break it down into two factors. Last example. This one is much trickier, right? Extremely tricky, but if you can figure this one out, then you're pretty much set. So this one is not quadratic because it goes from 3 all the way down to 1 and then 1. So the highest term is not a squared. And not everything has a cosecant. So instead I'm actually going to cut it in half, right? You can do that in math. I'm going to factor one half and then the other half. So in different colors, my first half, I have cosecant cube minus cosecant squared. I didn't do any factoring yet. All I'm doing is just dividing it into what I'm going to factor out. So for the left side, I'm going to factor out a cosecant squared here, and I get inside the parentheses cosecant minus 1. Here all I did was just take out a cosecant squared. And on this side, all I did was take out a negative 1. Right? I can factor out a negative 1. That's pretty easy. Now from there, I'm going to factor. So now that I factored both halves individually, I'm going to factor this entire thing. And this is important. This is where you have to take a big step back. But I notice that these two are in common, right? They both have a cosecant x minus 1. So I'm going to factor that out of this entire expression. This seems crazy, but trust me. Look at my writing. I get something like this. And again, I see an identity, cosecant squared minus 1. That sounds like cotangent. And again, I apply my factor that I took out from here as my final answer.